Okay, so today what I want to show is a small session of live coding in MetaCall Core, and our idea today is to implement a proof of concept of a new feature, and I'm gonna explain now what is that kind of feature. So basically, if we go to MetaCall, recently we have been doing very many experiments of mixing a scripting language with C and C++. So for example, here this guy was trying to call C code, these functions, from Python here. And in order to, normally when you can do things like this, let's say you want to import MetaCall and you are in Python, and then you can do from some.c, sorry, you can do this also, import some.c. This is valid in MetaCall. Once you import MetaCall, you can do this kind of imports, and then you have the function in Python in the global scope, and then you get the result. This is how it works if you don't use the specific API. I mean the complex API. But another option is sometimes you want to do more complex things, and instead of this, you can do. I'm gonna put the equivalent code with the classical API, which is import from MetaCall, import MetaCall load from file, MetaCall, something like this. And here we can do MetaCall load from file, C, some.c, and here we can do sum. This is calling a function that is called sum inside of sum.c, and then we pass here the numbers and we get 7. This is the equivalent code as before. Both are the same. But the most useful way is this, so you don't care about the internal API. But sometimes you cannot do this because, for example, in the case of this guy, he's trying to send an array or a matrix. It doesn't matter. He's trying to send a huge array to the function. And one thing that happens is that MetaCall always calls by value. By value means that it copies all the arguments. So if you have an example like the one before, if you do, well, let's say here you want to do this, some matrix, and then we pass two arrays. For example, this will give us the result 4 or 5. But the problem is that MetaCall interprets that this is an array type, this is another array type, and it copies the values to CLAND, and then it does the sum, and when it returns, it copies again. There is 3 copies of memory. Normally, it is okay when you are using an integer or something like that, but imagine that the array was so huge, it won't pay off. So sometimes you have to specify things like, I want to pass this by reference, which is basically a pointer to the internal array that is represented in Python. In order to do that, you need an API like this. You cannot do it. I mean, MetaCall cannot deduce this automatically. You have to do it manually. That's the point. So when you do this, instead of doing this kind of thing, you can do something like this. And see. So the idea is that we're gonna instead of this we are gonna pass by reference everything, and for doing that we need to do this. Let's say that the signature now is different and the third argument is the result. We should do something like this. Matrix sum, and now we pass this A, B, A, B, B, and here C, which is the result. And after this, here C will be equal to 4 and 5. That's the point. Instead of using an arrays, in C land, all arrays decay into pointers. It means that if for C program, an array and a pointer, it's the same. But this doesn't happen in Python. In Python, an array and a pointer is different. A pointer is represented by pcapsule type inside of Python, and the other is represented by an array. It's two different things. So you need this kind of API for specifying that you want to pass references to the functions in C, for example. Okay, so this is the context to understanding what it's happening, but in reality what it will happen is that for each language like Python, JavaScript, we will need to re-implement this kind of wrappers of the C MetaCall API. This is already happening here. For example, I have here a pull request. I started already to code this, and as we can see here, for example, I started coding here the implementation of MetaCall value reference for Node.js, and if we check this again in Python, sorry, this is we check here, it's the same. If you check the code, it's equivalent. It's 2 times the same code repeated again. It doesn't make sense to implement it, and it's gonna be very costly because the whole MetaCall C API, it's quite large. And if we have to implement this for every language, it's gonna give us very problems because it's gonna be very error prone because it's done manually completely. Also, it's gonna have it's gonna be very tedious because it's gonna be a lot of lines of code at the end that they have to be implemented in C. And as you can see here, the API is long, you see. We have to do all those functions for every language. It's a lot. And this is for the values only. Here is the MetaCall API, it's even longer. We have to do this manually for all the languages. It doesn't make sense. Okay, so the idea for this is something new, and it's something that we implemented a few time ago, but I knew that it was possible to use, but I never started giving it a real use. The thing is that when we have a loader of any code, normally we have one is load from file, and this in C loads C files, sorry, .h and .c in the C loader, okay? Second, we have load from memory, which is eval, And here it's like we do this with TCC, and this is like I don't know, it's passing a string. We pass a string with some code, for example. It's here, for example, we pass this. You can see here we can pass this and then we can call it. And the third thing that we have is load from package. Load from package. This is, for example, in Java, we can load jars here and things like that. But in C, what it represents is that we can pass an header and a so del or dine lib, and we can load libraries directly into memory. That's the idea. So what I was willing to do is by using this C loader, what if I load MetaCall itself? If I load MetaCall itself, I will have the C API directly inside of MetaCall. And once you do this, this allows automatically to use MetaCall on any language. And you get the C API exported into any language, even if it's the same C style, but we can later on do wrappers on top of it, like object-oriented or whatever we want, in order to not look like C. That's the idea. So my idea today was to do little steps in order to prove that this is possible, because I'm not sure it will be possible or if there is another problem. That's what I want to do. Okay. So if you have any doubt, you can ask now. But otherwise, I'm gonna start writing a test, and we will try to make if this is possible. Okay, so let's start. The idea of this is that well, I wanted to make another test different from the old one. I can use this one. It's a bit redundant, but it's what it is. We don't need this. MetaCall test. Okay. Okay, and now I'm gonna copy this. Let's delete all this. We don't need this. Okay, and now this. And now let's add the test here. Oops, here. Okay. Okay, so now my idea is define I mean, just load MetaCall as it is, and then call a function of MetaCall C API dynamically. I mean, like using FF5. So the first thing I want to do here, now let me check something. Yeah, I want to do exactly this. And for do this, library. For doing this, I have to let me think about it. I hate that. This is project output path, I think. No, I don't remember, but I have this here. This. This goes here, and then the header is let me see. It should be in somewhere in the code. Here. Yeah. It's this too. And I want to check another thing here. Maybe I don't need the other one, the other path. Oh yes, I need it. Okay. Okay. And this one, if I want to check how to get, there is in CMake, how to get the extension of a dynamic library. So, and I leave depending on platform. There is some variable that I no, this is not what I want. This. Yeah, it's exactly this. It's here. Okay. And there is also prefix, I think. Yeah. This is like this. Prefix, MetaCall, suffix. No, but I can do another thing. I can get it from here. It might be better. Yeah, with this it may be better. Yeah, this thing. I think this might be better. Okay. MetaCall. Okay, let's try it. And here, what I'm gonna do is I'm gonna copy this here. MetaCall, and I have to add here the paths. Okay, so I think this is wrong because it's the path what I have to pass here. Only the path. Like this. I think it's gonna work like that. I don't know. I wanted to check here. For passing the paths, there is a function, but I don't remember how. But there is an example here. Here. This. Why not? I think there was a, yeah, there's a function. Okay. This, and this. And this. And this. MetaCall API included. And now 0, 0. Okay, so in theory it should work now if we try it. Basically what we have done here is passing the include directories of MetaCall and telling MetaCall to load the... No, I'm gonna add here also this one, just in case. And passing this here. So the idea is that we register those include paths and linker paths, and then later on we load MetaCall itself in with the C loader. And once we do this, this is gonna print, this code here is gonna print all the functions that are located in MetaCall. This is the proof of concept I wanted to do, and let's try if it works. Let's see. Well, CMake first. So if this works, next step is gonna be calling some function inside of MetaCall through MetaCall and see if it works. And I think we can stop there. Maybe later on when they have more examples of, more data of this, and I have tried more things, we can keep continuing. But it will be interesting to at least, because what I want to do in the future is instead of using MetaCall to load itself here with the C loader, my idea is to generate on the fly all the stubs that register MetaCall into itself. It means that we generate a C file. Instead of doing this manually, I will have some kind of compiler or transpiler, I don't know, probably in JavaScript, because it's very easy to use JavaScript. And my idea is to export all this information here that is serialized into a C file that is generated on the fly, and it registers all the API. It's like just something like Rust bin gen, but instead of doing it from C to Rust, it's gonna be from MetaCall to C code. And by that way, I wouldn't need to use the C loader when distributing MetaCall itself, and it will have all the stuff registered into itself in that project. In the project itself, without requiring anything external. That's the idea on the long term, after making this proof of concept. And let's see if something failed. This. And I don't know, I think it's a pretty cool feature, because it's gonna unify all the interface, and I don't know, it's gonna be more easy to implement more languages in the future. That's more or less the idea. Simplify all those things. Okay, work now. It didn't work. Let's see. Let's debug it directly. Maybe I have to change things to make this simpler, because I don't know. It may be. It may not be complete enough, because here I do many assumptions. For example, I'm assuming that library is called metacall.so. Maybe it lacks the lib here, and it must be the same name as the header. This is an assumption that we should change this, but I don't know how, because the API only accepts one parameter. Maybe we have to change the API. it didn't hit the breakpoint. I don't know why. I don't know what's happening. It's not hitting the breakpoint for some reason. Yeah, I don't know why it doesn't hit the breakpoint. That's crazy. I need more CPUs. I'm gonna set up a new computer of 72 threads next week. I will have more cores by then. But now it doesn't seem it's enough. 24 is not enough. It's not enough. It got bugged. I don't know. This doesn't happen. I mean, this is only happen when you do a stream because it's crazy. It's crazy, man. It's not working. I don't know why. I mean, I don't know. Okay, in any case, I mean, I can go further if this is feeling like that. I don't know what is doing that. I don't know. This is things that only happen during the stream because I've been debugging this a lot of time. I don't know what is happening. It's crazy. What about now? Let's try again.
Still fails, right?
Hmm?
Still fails.
Yeah, I don't know. It's insane.
Mhm.
I mean,
I have that rapid JSON. I told you about it, the Rust port.
yeah, it says the same problem. Let's see. Let's try it. But
Okay.
the thing is, it doesn't make any sense, you know? It should stop the breakpoint. You see? Yeah, it's the same problem, but it's because of this. It doesn't fail now. You see? Yeah, you see? It worked now. It was lacking the repetition.
The
But it
rapid
doesn't make
JSON.
any sense, bro.
Okay.
This is the first time that this happens to me in Visual Code. That's why Windows is better. But I don't know. I mean, we can stop the stream. Once I solve it, I can show it again in the second part. At least you know now what I was trying to plan to implement. The idea is that the next thing to do here is, for example, let's say one random API. I'm gonna code it, and as I can debug it, but at least, well, let's code it. Here in MetaCall, we have, for example, these kind of functions that they give the version and things like that. We can call some of these functions, and then we can get the results. You know, for example, this will return a string. So what we can do here is MetaCall, and when we don't pass anything here, return. We get the return here, and then we can do something like that. We copy this, and here we check that return is not null. We check that the return value is a string, and then what we can do here is expect string equal in here. What we do is MetaCall value to string, and I don't know.
I think should remove the long on the other side of the equal.
Yeah, but I want to check only the first n characters. You know what I mean?
Okay.
and maybe it's not the best. Yeah, we can do something like that and it will work. You see, that's the bug. But I only want to check first n characters. I don't know if it's possible. No, it doesn't let you. Okay, I'm gonna do it in the old way, which is like this. Int 0, and here we will do string and a comp. String and a comp. String here, I'm gonna check the first 10 characters of this function. It's here. 1, 2, 3, 4, 5, 6, 7, 8. And here 8. Okay, so the idea is that when we return this, it will call the MetaCall function, and we can do it dynamically. This is being done from C to C, but in the future this part will be JavaScript, for example, and we will have all the API we want. That's the point of this. And it should work. I mean, the debugger, but I don't know what it doesn't work. It's insane. But this is more or less the code that we need for testing that. I'm gonna add a breakpoint in another point to see if it works. Here. Let's see if it works here. Oh yeah. It worked. I don't know why, but it works. I don't care why.
I don't care.
I don't care. I don't give a fuck. Oh, yeah, I don't know if I can say that on YouTube. Okay, so the idea is to see what is happening here. Let's see. Let's see what it does. Okay, it's finding MetaCall, but I think it's because the prefix is not live MetaCall, you know? We should test that too. Let's see. No, it should work. That should work. Let's run again. No. I hate this because in Windows, in Visual Studio C++, it works much better than here. But here, the breakpoint set, I mean, very randomly. It doesn't go to the next line properly most of times. I mean, I prefer Linux, but debugging in Windows is much better. At least for me. And path is build more platform name, and platform name is MetaCall.so. And what it doesn't work, it should work. Yeah, I know what is happening. I know what's happening. It's because when we compile MetaCall in debug, it adds the... I forgot that thing. We need this. I'm gonna copy everything. Like this. Well, I'm gonna do something before. I'm just gonna copy the library. That's it. It should work now. Yeah, it works now. Wait. Oh, it can't find now the headers, I think. That's the problem now. And file is files. Let's see what it is. Yeah, it's okay. MetaCall.h. I think that's the problem. It has no extension. Okay, I think it's gonna be very problematic now. because there is, I mean, this API here is not good enough. I think I should add the extension to the header here. I think I'm doing that already. Add header is doing this already. And why it's not working? Let me check again. It's not finding it for some reason, but I'm testing against it. I don't know. In any way, it was this a little bit idea of the test that I was writing. My idea is to load it and see if it works, but what I'm seeing now is that the package API for MetaCall for C code it's very weak. We should improve this because it will be good to specify here directly the headers and the library path instead of doing it like this. We have to think a way to handle this in C. It's because it's a more complex language, and this kind of things will be needed in the future for sure. I mean, when you are requiring libraries from any place, you want to pass all the headers and the .so file or the del file or things like that. You cannot assume things like this. I mean, this assumes that the library is lib metacall.so and the header is metacall.h as header, but this doesn't happen always because sometimes the headers are split in multiple instead of one, or the name of the library is not the same name of the header. So I think it's almost 1 hour. We should cut here, but the idea today we have noticed that this API is not as complete as we need for handling this kind of cases. I'm gonna work off that, and once I have this more advanced, we can do another meeting later today, and we will show. I will show how it has been going with the improvements of this. But more or less, this is the test case, and today we did a little bit of test-driven development. We developed the tests, and now the idea is to implement and do the changes to make the test pass. So if you have any doubt or any suggestions, otherwise I will cut the recording. I don't know. And in any case, thank you so much for attending, and see you later.